So now let's discuss the second task. We are given a production function of country, and it is equal to y is equal to 8k in the power of 1/2 and L in the power of 1/2. Capital is fixed and is 10,000, and what will be the employment if real wage is 20? So real wage is 20, that means pay for labor will be equal to 20. K is equal to 10,000, and we need to find the employment. So first of all, we need to find marginal product of labor, and it is the derivative of the total product. So we take 8k in the power of 1/2, and then we take the derivative of L in the power of 1/2, and we take this power before the L, and then we subtract 1 from it, and it becomes minus 1/2, and we can put it in the denominator as a square root of L. So now let's just put our numbers here. 8 multiplied by square root from 10,000 multiplied by 1/2 square root of L, and it will be 8 multiplied by 100 divided by 2 square root of L, and it will be 400 divided by square root of L. And we know that marginal product of labor will be equal to wage or pay for labor, and will be equal to 20. So we can write that 400 divided by square root of L is equal to 20. And we now need to solve this equation for L. And we just rewriting it and divide by 20 and get that 20 is equal to square root of L, and this means that L is equal to 400. And this is the answer for this task. Hello? Okay. So guys, now we will consider one extra task about how to draw a joint production possibility frontier. So firstly, let's see what task do we have. So we are given two tables about east production and north production, and west production. It is west. And these are two factories, and each factory produces cars and radios, and we have computed amounts that if Hello guys, let's consider one extra task about how to draw a joint production possibility frontier. We are given two tables about Eastern production and Western production, and these are two factories. Each of them produces cars and radios, and we see from the table that if Eastern production produces only cars, it can produce 100 cars and 0 radios. And if it produces 50 cars, it can produce only 25 radios. So we need to draw a joint production possibility frontier. But first let's consider our algorithm, how we can do it. So the first step is to analyze the table for each factory. Then we will need to draw a graph for each factory using given points from the table. Next, we will find the equation of the line using any of two methods. I will consider both of them, so you can use the one you prefer. And then we will find the opportunity cost for each factory using the table or the graph. We will make a decision what type of product will be more efficient to produce for each factory. Then we will build the joint production possibility frontier. For this, we will mark points where both factories produce the same product. Then we will determine the amount produced by each factory when they produce different products at the same time. Then we will connect points, find equations of lines on the joint PPF graph, and finally we will write an equation for production possibility frontier as a system of equations. So let's start with the first step. So in the first step, we need to analyze our table and draw the graphs. So we see from the table that if the Eastern production produces only cars, it can produce 100 cars. So we will put this point here. And we can also see that if Eastern production produces only radios, it can produce 50 of them. So it is our second point of the graph. And we just can connect them. So the same thing we can do with the Western production. So if the Western production produces only cars, it can produce 50 and 0 radios. And this point is here. And if it produces only radios, it can produce 100. So this point is here, 100. And we can also connect these 2 points. So we have made a graph for each factory with given points. Now let's find the equation of the line using any of two methods. So our first method will be a little bit faster, but it's a little bit more difficult. So we need to find the equation of the line which passes through these 2 points. I will mark them. So it is A point and it is C point, D and F. So our production function should have an equation. C is equal to A minus B R. So where C it is cars, R is radios, and A and B are our coefficients. So coefficient A is intersection with y-axis, and basically we know this coefficient already because we can see on the graph that our point here is 100. So we can write that A is equal to 100. But we don't know anything about coefficient B, and coefficient B is responsible for the slope of our line. So to find this coefficient, we will need to use coordinates of the point C. So this one. So we will use its coordinates and put them into our equation. So our equation now is C is equal to 100 minus B multiplied by R. And the coordinates of point C are 50 and 0, because on the x-axis we have radius. And so cars are here, radius are here. So instead of C, we will use the amount for cars, and instead of radius, we will use our amount for radius. So we will write that that 0 is equal to 100 minus B, because we don't know this coefficient yet, multiplied by R, our radius. And we get the equation that 50B is equal to 100 and B is equal to 2. So, and now we can write the equation. So our cars are equal to 100 minus B, which is equal to 2 multiplied by radius. So, and the second equation for the Western production I'll find using another method. So another method, so it was the first one, now it is the second method, and basically we have here just one formula which we need to use. It is the equation of the line passing through 2 points. So we will need to use the coordinates of our points. So for the second case, we have our point D. So coordinates of the point D are 0, 50. So please pay attention that in the table we have firstly 50, then 0, because firstly we have cars and then radius, but on the graph we have coordinates 0, 50, because firstly we take the coordinates from x-axis, then the coordinate from y-axis. So don't make a mistake. And our point F has coordinates 100, 0. So this coordinate is x1, this coordinate is y2, y1, this coordinate is x2, and this coordinate is y2. So now let's write our equation. X minus x1, in our case x1 is equal to 0, x2 is equal to 100, 100 minus 0 is equal to y minus y1, it is equal to 50, y2 is equal to 0, and y1 is equal to 50. So we simplify this equation. So minus 50x is equal to 100 multiplied by y minus 50. So we divide both parts by 50. Minus x is equal to 2 multiplied by y minus 50. Open the brackets and we'll get 2y plus 100. 2y is equal to we have here minus 100. So 2y is equal to 100 minus x, and y is equal to 50 minus x divided by 2. So we remember that on the y-axis we have cars, on the x-axis we have radius. So our function will look like cars are equal to 50 minus 0.5 radius. So we are done with this step, and the third step. Now let's consider the fourth step. We need to find the opportunity cost for each factory using the table or the graph. So let's use the table. Here we need to find the changes in our amounts of cars and radius. So if we move from the first row to the second row, we need to give up 50 cars because it is minus 50 for cars and plus 25 for the radius. And we can use these numbers to find the opportunity cost. So minus 50 and 25. So we write them down as 50 cars and 25 radios. And we need to divide both parts by 25, and we will receive that 2 cars are equivalent to 1 radio. So 1 radio is equal to 2 cars. This means that to produce 1 radio, the first factory needs to give up 2 cars. And what does this coefficient mean? Actually, this coefficient is just the slope of our line, and we can so it's the opposite of the slope of our line, because our in this case the slope of our line is equal to coefficient b, as I already told you, and it is equal to 2. So that's why this ratio is equal to 2 and 1. So we can obtain it from the graph if you want. Now let's do the same with the Western production. Here we have minus 25 for cars and plus 50 for radios. So let me write, so it's opportunity cost for Eastern production, and here I'll write opportunity cost for Western production. So here we have 25 cars equivalent to 50 radios. So let's divide both parts by 25, and we will receive that a car is equivalent to 2 radios in case of Western production. So we can, so yes, to receive the ratio in terms of radius, we will need to divide it by 2, and here we will receive 0.5 cars and 1 radio. So this means 1 radio is equivalent to 0.5 cars. So, and it is our opportunity cost for Western production. So we have done the step 4. Let's do the 5th step. We need to decide what type of product is more efficient to produce for each factory by analyzing the opportunity cost. So we see that to produce 1 radio, Eastern production needs to give up 2 cars. So I'll write need for 1 radio needs to give up 2 cars. And here Western production for 1 radio needs to give up only 0.5 cars. And this means that Western production should produce cars, because the opportunity cost for Western production for producing cars is less than the opportunity cost for Eastern production. And Eastern production then should produce radios. So we made a decision about what type of product should be produced by each factory to optimize the results. And now we are ready to build the joint production possibility frontier. So let's draw it together. So here are our axes, and so let's say this will be 50, 100. So again 50, 100, 150. On the y-axis we have cars, on the x-axis we have radios. And according to our plan, we need to firstly mark points where both factories produce the same product, and it will be intersection with x-axis and y-axis. So what will happen in the situation where both produce cars? So both factories work on car production. So how many units can we get? So as you can see from our two graphs, we see that the first production unit can produce 100 cars if it only produces cars, and West production can produce 50. So we should sum up these two numbers, 100 and 50, and it will be our amount if both factories will work on car production. Now let's look what will happen if both factories decide to produce only radios. In this case, the first one will produce 50 of them, and the second one will produce 100. So again, we will receive the amount of 150 radios. And it will be our second point of the graph. Now let's look at the algorithm. We need to determine the amount produced by each factory when they produce different products at the same time. As we decided, the Western production has to produce cars, and this means we need to use the production function for Western production to determine how many cars it can produce. So our production function for Western production is equal to 50 minus 0.5 radios. So R is equal to 0 because we decided that the Western production will produce only cars, and the number of cars is equal to 50 because this part becomes 0. So, and in this case, we know that Western production will produce 50 cars. So we should move 50 points down the y-axis. Now let's determine what will happen if Eastern production will produce only radios. So we take the function for Eastern production, which is equal to 100 minus 2r, yes, and in this case the number of cars is equal to 0 because we decided that Eastern production will produce radios. So we write that 0 is equal to 100 minus 2r. 2r is equal to 100, r is equal to 50. So we know that our Eastern production will produce 50 radios, and we need to take this amount from the x-axis. And we need to draw the line like this until we receive the point, the third point of our production possibility frontier. And we should now connect all the points. So first connection, the second connection. So it was how we can build our graph. Now let's see what we should do next. So we have done all these steps. Now let's find equations of lines on the joint PPF graph. So you can use any method you want to use. So let's name the points somehow. I don't know. Here let's put M and K. So coordinates of M point are 0, 150. Coordinates of N point are equal to 100, 100. So let's I'll write them here again for convenience. And for K point, we have coordinates 150, 0. For finding the equation, I will use the method of coefficients. So we know that the intersection with y-axis is when a is equal to 150, and we need to plug in the coordinates of the point n, and they are equal to 100, 100. The 100 is equal to A minus B multiplied by 100. So 100 is equal to, so instead of A we use 150 minus B multiplied by 100, and we receive that B is equal to 0.5, and this means for m to n our equation will look like 150 minus 0.5 radius. So for m to k, so it was m to n, and now we have n to k interval, and in this case our system will look like 100 is equal to A minus 100B. This is because we are plugging in the coordinates of this point, because we don't know where this line, which passes through the points N and K, where this line will have an intersection with y-axis. That's why we use coordinates of 2 points. And the coordinates of the second point, K, we use also in this equation. And now we just solve the system. 100 is equal to 50B, and 0 is equal to A minus 150B. B is equal to 2. 0 is equal to A minus 300. So we put B into this equation, and A is equal to 300, and our equation of the line from N to K is equal to C is equal to 300 minus 2 radius. And now our final step, we need to write the equation for PPF as a system of equations which we received in the previous step. So once again we received this equation and this one, and now we need to write a system of equations. So firstly we need to take a look where our line from M to N will be ended. In this case, from R, which is equal to 0, so this period, through this period, our first line will be drawn on the graph, and from R is equal to 100 to R is equal to 150, our second line from N to K will be in the system. So the first part is from R is equal to 0 and r is equal to 100. And the second period is from 100 to 150. And here we write the equation for, so let's write like this. C is equal to, here the equation of the first line, and here the equation of the second line. So that's it for this big task. I hope it was useful for you. So if you have any questions, you can write them in the comments or in Teams. So we will be glad to answer them. So that's all. Thank you.